Station, this is Houston. Are you ready for the event?
I think we're ready for the event.
WGBY-TV, this is Mission Houston Control. Please call station for a voice check.
I hear you loud and clear.
Great, Cady. It's such an honor to have you.
Can you please complete? Thank you.
And could you say again? We're just getting configured here. Sorry.
Station, this is WGBY-TV. How do you hear me?
I hear you loud and clear. How me?
Station, Spectrum Route 1.
We hear you well.
So WGBY, do you hear me?
I do. Can we proceed with the questions?
I am ready.
Great. Cady, it's so great to have you here. As a veteran of 2 shuttle missions, can you talk about how different it was between your missions with the space shuttles and going aboard the International Space Station on a Russian vessel?
Well, the Soyuz fits 3 people, and so it's very, very small. Sorry, we're just configuring audio here, so I'll start again. The Soyuz is a smaller vehicle, and it really just barely fits 3 people. And so when we're in there, we're sitting pretty close, and we're very close to the outside of the vessel. So I would say, in the space shuttle, you feel like you're in a spaceship and you're on your way to space. And in the Soyuz, you feel like you are the spaceship and you are hurtling into space. So it really feels a lot closer. I mean, just about 3 inches from your right foot is the outside of the hull. So it's pretty exciting.
What's been the biggest surprise so far with your work aboard the space station?
Well, I'm both surprised at how quickly we get used to microgravity, at just, floating around and just being able to, move with just a few fingers controlling our movements. And so how quickly we get used to it. And at the same time, I'm surprised that I'm always learning new things and new ways to do things in a zero-G environment, and realizing new possibilities that I hadn't actually anticipated. So I think just the delight of living in a
I lost her.
Okay, sorry about that.
Hey, that's okay. It's just a busy day here, and we had a lot to do, a lot of, things that needed done at a certain time, and this is just the way it is sometimes. I think we just adjusted the lighting as well.
I understand. And I know it's been extremely busy aboard the space station. Can you talk about some of the work that you've been doing?
It's been a really exciting time because we've had several supply vehicles, in fact, from all the international partners. It's kind of normal, or, not every day, but every few months a Russian Progress vehicle will come up here, a Russian supply vehicle, and will bring supplies and take away trash. But now this year we have both the Japanese supply vehicle, the HTV, and also the European Automated Transfer Vehicle, which is a European supply vehicle. And until yesterday, we had all 3 of those here on the space station at the same time. And what that means for us as a crew is that there's a lot of loading and unloading and organizing of new supplies and actually organizing of things that we want to get off the station. And in fact, the HTV, which we just released yesterday with the robotic arm, Paolo Nespoli and I were operating the robotic arm. And so literally we take the Japanese supply vehicle, the HTV, off of the station and hold it out into free space, release it with the robotic arm, and then it actually we send commands to it, and it actually backs itself slowly away from the station, and then we'll re-enter the Earth's atmosphere just tomorrow. So it's been a very exciting time to have these vehicles here, and especially with the Japanese supply vehicle. It has a very large hatchway, which means we could put very large pieces of equipment or things that we don't need aboard the station. And that's been really valuable to clear out space for new experiments and new supplies that we do need for the lifetime of the station.
So what is it like using that robotic arm to reach out and actually grab a hold of another vessel?
Well, it's not something we do every day, and in fact, from the space station here, we've only done it twice. This was the second time where I got to be at the controls of the robotic arm and actually reach out. The Japanese supply vehicle was hovering just about, a few feet from the space station, and reach out and capture it with the robotic arm. And, I've practiced that a number of times, and certainly all the times I was required to practice, and probably a bunch more after that. And so I knew I could do it, especially if that vehicle was pretty well behaved. But at the same time, to do something like this, you get a little bit nervous, at least I do, and part of you kind of wonders, are you going to make a mistake? And the way that I get over that kind of nervousness is just to say, I've done all the practicing that I can do, and so I've done all the practicing that I can do, and so I'm just going to have to do my job.
April 12th marks the 50th anniversary of manned spaceflight, and I'm curious, what does it feel like to be up in space at this sort of historic point in time?
And stand by just a minute, WGBY.
Houston, should we move to 2 for this continuation of this PAO event? Copy.
Mm-hmm.
Well, in WGBY, I know this is to tape, and so I knew you could be a little bit forgiving. We're just trying to get some things straightened out. It's actually one of the logistical things up here is that we basically have 2 channels to talk to the ground. And often, there's 6 of us on board here most of the time, and we're each doing, 6 different things. And so it would be nicer to have more channels, but that's one of the capabilities that we're working on for the space station, because we are now doing so much more work up here.
Yeah. Wow.
So I think your question was about the 50th anniversary. Was that correct? I heard most of it.
Yes.
All right, I did hear the question, if you're ready.
That is, yes. Sure. Yeah, if you want to go ahead and answer it, that'd be great. Just about the 50th anniversary, what it feels like to be up in space at this historic point in time.
Somehow, when we have anniversaries, it's I think pretty special, because it makes us, the fact that it's been 5 years or 10 years, or in this case 50 years, 5 decades, that people have been going to space, and started by Yuri Gagarin with the very first flight. When we have, sort of even numbers like this that cause us to think about it, I think it's great, because it makes us realize how far we've come. It also reminds us of the goals that we have had. I mean, we live in a universe. Granted, we live on planet Earth, but planet Earth is part of a universe, and it's our neighborhood. It's our I think, our path to explore it. And the fact that we are on a path, and that we have come this far, the fact that I can, call home from space, and it's considered to be a normal thing, I think that we've really come a very long way. And I'll tell you that I am very pleased and honored to be up here during a time when everybody takes a minute just to think about really how special our job is, and how great it is that real people are living in and working and doing really interesting science experiments in space every day.
Cady, it's a great honor to speak with you, and thank you so much for your time today and the hard work you're doing up there.
It's really nice to talk with you too, and I know that we've had a great in Worcester, Massachusetts. It's just been great to have your station on board for the longest time, and in fact, I listen to the news up here, so I get to hear some of you.
station. This is Springfield Technical Community College. How do you hear me?
Springfield, I hear you loud and clear. And how do you hear me? Great. You know, I'm really happy to be with you today. I know it's taken a lot of organization on the part of a lot of different folks to organize this event, and I'm just really thrilled that we're doing this in Massachusetts. I've had some beautiful views of Massachusetts during my time up here. In fact, usually about twice a day I can see Massachusetts, and it is a beautiful, beautiful state.
I'm Tamara Rivera from McMahon. Have you ever made a mistake but then worked together as a team to solve it?
You know, we certainly have made mistakes. All of us up here, individually and as a team, we've made mistakes. And that's really why we practice. You know, one thing is to learn about the mistake itself, and then the other thing is to understand, you know, how we as people react to that and how we react as a team. And what I really like about the people that I work with, you know, both up here in space and down on the ground, is that, you know, we're all upset when we make a mistake. We don't like it. We wish we didn't. But what we're doing, our job up here, is more important than yelling at somebody for making a mistake or being mad at them about it or being mad at yourself. Our job is so important and important to do correctly and safely that we just have to put that behind us and get on with the work. And I really like that about the people I work with.
Hi, my name is Angelica Nave. I'm from Kelly School. Will a dog or other animal ever come to live in the space station?
Well, I don't know about, they could come here, but I will tell you it's taken me a little while to get used to living up here. In fact, it's funny, we do a lot of walking around, you know, with our hands. In fact, I was just doing a training exercise where I had to carry around our pressure reading gauge, and it's a big thing about this big. And my partner up here in space pointed out that it would actually be easier for me to carry this thing around in the modules if I actually just kind of like, you know, hooked it between my knees here, and then I could just carry it around, and I would have my hands free to make sure I could find a path and not get off balance as we tried to go quickly through the modules. So it's been hard for us to learn how to move around up here, but I imagine that dogs and cats and all the other creatures would adapt as well. We actually bring some of them up here to do experiments. We've had mice up here. We've had all sorts of insects up here, and fish and worms. In fact, we have worms up here right now doing experiments. And the reason is that all of these creatures have some things in common with us as people, and we can learn about what affects these the worms or whatever insects or animals we're talking about, what affects them up in space, and it helps us understand what affects people up in space, so that we can then go on to really know what's going to happen when we are further away from home and spend a long time away from home in space on our way to Mars.
Hi, my name is Emmanuel Ortiz from STEM Middle Academy. My question is, how do you keep in touch with your family, and how does your family deal with you being in space and away for so long?
Well, Emmanuel, I get to call home, so to speak. I call home, I would say, almost every day. I've been up here just about 102 days now, and I think I've only missed 3 days in terms of calling home, because we have an internet protocol phone that we can use when we have the right satellite coverage. So somehow I find some time to call. I think the bad thing is that they can't call me, and that makes it a little bit, you know, hard for them to always be the ones who get called. And if the satellite coverage ends, then, you know, I can't really call back right away. And they've gotten a little bit used to that. But I think, you know, when you're a family and when you have a close relationship, you just learn how to be happy about the communication that you do have. And so we try to talk about our days and how our days are going. I read to my son and read stories just like I would at home. And we just try to make the most of the communication that we have. We also have video conferences once a week, and those are great.
Hi, my name is Laura Ernst from McMahon School. How does the ISS help prepare astronauts for a future voyage to Mars?
Learn in lots of different ways. We're learning about, there's sort of the equipment side of things, about how to run a spaceship and how to make sure that a spaceship runs. I'll give you an example. We can't bring all the water that we need up here, and so we recycle our water. And I know that sounds kind of yucky, and actually I guess it is kind of yucky, but I'll tell you that when I go to the water dispenser and get water, it tastes beautiful and clean. But we are actually recycling all of our sweat, all of our urine, all of our, old water. And that seems to work out pretty well. But I'll tell you that the recycling system has been running differently than we expected when we designed it. And so we're learning lessons about how to make a water recycling system. So there's that equipment side of things. And then we're learning about how people react to being up in space. We actually lose bone mass up here because we don't walk around on our legs, and we don't send those signals to our brain that says she needs these muscles and bones. So we don't walk around on those legs, and so we actually lose bone mass at a rate about 10 times of like an older person that has osteoporosis. So we're learning about how exercise and medicines can help us prevent that. That's a good question.
Hi, I'm Carlos Medina from Kelly School. What are the positive points and the downsides to being on the ISS?
Well, for the downsides, I'm not really sure I can think of one. I mean, I know I'm away from home for a long time from my family, and there's some things that I miss. There's food that I miss. There's people that I miss. But I'm in an amazing and wonderful and magical place where, life is really different, and I'm learning more about it every single day about what I can do living in a weightless environment. I mean, first of all, it's really fun. So I just don't think that there's a lot of disadvantages, and those disadvantages that I mentioned are the same as a lot of our military people that are away from home and serving their country. I mean, they're spending time away from their families, and they're not in nearly as nice or exciting a place as this, and they don't get the view that I have to be able to look down at the Earth and see amazing, amazing things on the Earth. So there are advantages and disadvantages, but I'm really, really happy up here, and I don't really actually want to come home very soon.
Hi, I'm Janelle Bryan from STEM Middle Academy. My question is, what happens if you have an unexpected medical emergency on board?
It depends on the emergency. We're all medically trained, not to be doctors, but to do a lot of different procedures, and especially we have an automatic defibrillator up here if somebody has some kind of a heart problem. So we're well trained in all the basic procedures, and the ground is just one phone call and one video call away, and we have doctors that are there all the time. And so we can always call and get their help, and if it's something where they need to show us something or tell us how to do something, then we have ways, and we've practiced ways of doing that. And if it's really an emergency, we could actually be home in probably about 15 hours. Because we just climb in our Soyuz, in our spacecraft, and deorbit and land on the Earth.
Hi, my name is Ana Diaz, and I'm from McMahon School. My question is, do you remember the exact time you realized you wanted to be an astronaut, and what did your family and friends say when you shared your dreams with them?
Anna, you might find this surprising, but when I was growing up a long time ago, it was actually strange for girls to become astronauts. Now, I think you probably could think of a couple of women astronauts, and so I think it's really great. But when I was growing up, it was something I didn't even think of until I met Dr. Sally Ride. And she didn't remember meeting me. We've talked about it since. But all of a sudden, I looked at her, I shook her hand, and I thought, well, she's a real person, just like me. And maybe that means I could do that job. And that's actually why I'm here talking to you today. Not so much so that all of you become astronauts, but so that you realize that people who do the jobs that you think are so cool and amazing, those people could be you.
Hi, my name is Reniel. I come from Kelly School. Here's my question. After the recent earthquake in Japan, have you noticed any changes to the Earth?
Darnell, we have noticed, we've been taking pictures of Japan specifically, and just looking down with your eyes, I don't see much difference, although I think you can see changes in the water around Japan with more sedimentation. But we've been using very big lenses to take detailed pictures of Japan to help people on Earth understand the extent of the damage and places where people might need help. So every time we go over Japan, we try to take pictures, and so we do notice some things.
Hi, my name is Divine Davis. I'm from STEM Middle Academy. As you orbit the Earth, can you see the impact of humans on the environment from space?
Yvonne, we can see different impacts. One of the easiest ones to see is looking at the coastline. We can see different amounts of sediment, out into the water. When we're going over land, can actually see, regular patterns of where land has been farmed or cultivated. So it looks different than, where there's not little straight lines, where things haven't been cultivated. We can see the burning of the rainforest. We can see lakes that over time are gotten smaller and smaller and smaller. People have taken pictures of, like, for example, Lake Chad in Africa, for years and years and years from space, and we can see that it's become smaller and smaller and smaller, so we can understand that there's the effects of different droughts. It's a really interesting vantage point up here, and it's beautiful.
Hi, my name is Megan Damaris from McMahon School, and my question is, what kinds of experiments are you doing right now, and are any long-term?
Again, most of the experiments are long-term in that they're going on for a long time here, and some of them have samples that come back to Earth. Some of them, the data is right up here on the space station. I just started an experiment this morning called nanoskeletons, where we're actually looking at different ways to form crystals up here in space. And crystals form differently up here in space because down on the ground, building a crystal or having a crystal grow is kind of like building a brick wall. And if all the bricks really could be exactly where they'd like to be, they'd actually all be in a row. But sometimes gravity will make one of them sit down crooked. Well, the friends of that brick don't know that he's sitting down crooked, and they sit down crooked on top of him, and suddenly we have a brick wall that has straight parts and parts that are not in the right place. And so those can be defects, for example, in electronic crystals that we use for computers. So there's lots of different kinds of experiments. The ones that I think are really interesting, at least for me to look at, involve growing crystals and also fluid experiments. Fluid experiments where we get to understand what the fluids are doing, and that's pretty neat because they all float around.
My name is
This is Mission Control Houston. We're in a break as we hand over from one satellite to another in the Tracking Data Relay satellite constellation. As soon as we get the satellite signal back, we'll resume our event with Cady Coleman aboard the International Space Station and students at the Springfield Technical Community College in Springfield, Massachusetts.
Cady on one. We're just waiting for KU to lock up. Cady.
Okay, Springfield, go ahead.
My name is Damaris, and I'm from Kelly School. On the next space shuttle mission, STS-134, an orb spider is being sent up so scientists can study how it makes its web. Are you studying any creatures in space right now?
We have some worms up here right now, and they're so tiny they don't really look like worms. They look like little dots. But we're trying to understand how they actually multiply in space and what their structures are, if they're any different when they don't have gravity to worry about. And I think it's going to be really interesting to see what the spiders do. When you think about making a web, they must take gravity into account. They must think about the parts, how they have to be structured on the parts where they might be more likely to fall. And up here, where you're not more likely to fall from anywhere because everything's going to float, I'm thinking that they will become different kinds of spider engineers.
Hi, my name is Francesca from STEM Middle Academy, and my question is, How do you all get along on the ISS, and how do you resolve conflicts?
Francesca, because we're up here in this totally marvelous and amazing place, it's a little easier to get along than you might think. But we do have our differences. And the thing that I try to do, and I'm not always successful, but what I try to do is I try to remember that when there's something about somebody that I don't particularly like, or maybe is just different than the way I do it, sometimes I think, oh, we should do it my way. But actually, the best thing is to realize that when you have a group of people together, everybody in that group does something better than you do, and you do something better than they do, and together that makes a really powerful team. And so when something is a little different and maybe you don't like it, think, well, wait a minute, what does this person do that they do better than I do? I'm going to have them do that, and I'm going to do the things that I'm good at too. Then you become a great team.
Hello, my name is Dominic Evans from McMahon School. Do you get tired physically in space even though your muscles are not working against gravity?
Dominique, we do get tired, partly just working really hard. I think my head gets tired. You know, we work pretty hard every day, and at the same time, we also do almost 2 hours of exercise every day, and that's because our muscles don't get a workout unless we actually do some exercise, and we use a weightlifting machine that is based on vacuum. So I'm literally pulling against a cylinder inside a cylinder that that has just air, no air back there, and when I pull, it's really hard. And so we can adjust the weights to make them hard for us. And I do all sorts of exercises. I do squats, and I do deadlifts, and I do arm exercises. And so I will be actually very tired at the end of a day.
Hi, I'm Evander Barrios from Kelly School. When will Robonaut 2 be activated and working on the ISS, and what will his jobs be?
We are all very anxious to activate Robonaut and start him working. Although I will clarify that, you know, in terms of what he's up here for, he's up here so that we can understand what robots can do and how the way they work is, mechanically is affected by the lack of gravity, so to speak. I mean, let's say I want Robonaut to reach out and then push a switch, whatever he gets some signal. Well, without, you know, on the ground, all those calculations that tell Robonaut how far to put his hand out and then how hard to push on the switch, they all take gravity into account. And so when we take away that variable, we need to understand how to change all the equations that define his motions. So that's one of the things that we'll be looking at. And we'll also be looking at how people and machines work together. What's scary about that, what's interesting, and what are the possibilities that we haven't even thought of. And that's why Robonaut's up here. So it'll be pretty fun once he starts, but it's going to be a little while. We have to get his software up here, too.
Hi, I'm Damani from STEM. On the ISS, you work with people from all over the world. Have you ever had any problems with communication?
I don't know if I would say problems, but I will say that, you know, we all come from different countries. The major sort of partners, or the major languages, I'll say, up here are Russian and English. And so all the U.S. partners do our best to learn Russian, and the Russians do their best to learn English. And at the same time, sometimes we do have, you know, times that we think we understand what each other says, and it's not true. So we actually always have to be listening for when we might have a miscommunication, and just explain patiently to our other crew member, or vice versa, that we've misunderstood. And we work out those systems while we're training together, and so we're pretty good at it by the time we get up here.
Hi, my name is Justin from McMahon School. What does it feel like to be in the Space Shuttle or Soyuz during liftoff?
Jason, it is so exciting. It's pretty amazing. You know, you're sitting so close in the Soyuz, so close to two other people. I'm on the right side, and Dima's in the middle, and Paolo was on the left. And there we all are with our knees almost touching each other, and we're in a spaceship, and the clock is counting down. And I will tell you, when that rocket lit off in Kazakhstan, it was totally, totally amazing. And immediately you are just hurtling through space, and it's happening so fast. And it's mostly, I think, just really exciting because you realize that here you are, a regular old person who just worked hard, and you're getting to go to the space station to live and work up there for 6 months. So it was really just exciting to be on that journey. And 8.5 minutes later, there we are in space, and that was pretty neat as well.
Hi, I'm Gilberto Maderos from Springfield Academy. What happens during an emergency on the ISS, such as a fire?
Now, that is a great question, and one of the reasons why I just came all at the very last minute to our interview today was that we were practicing what if an emergency happens, and that's what we do. We practice those things and make sure that we don't just kind of know the plan in our head, but we've actually practiced it together. Who's going to do what the valve that you're supposed to go and close, what that really looks like. The emergency that we practiced today was, what if there's a hole in the space station? What are we going to do? And we have a system. We've got a really big space station, and the first thing we do is actually make sure we're all safe, and then we close one of the hatches in the middle, and we figure out which half is leaking. And then within that half, we figure out which part is leaking. And while we do that, we always make sure that we can get to our rescue ship, which is always attached to the space station. So we practice those kinds of things, and the same goes for fire and other emergencies that happen up here, and we take them very seriously.
I'm Sean Rodriguez from STEM Middle Academy, and my question is, if you can go anywhere in space, where would you go?
If I could go anywhere in space, I'll tell you I'm very happy just orbiting the Earth like I am 16 times a day. I mean, I just love being up here. But if I could go to other places, I think I would go to Mars, as soon as I could, because that's the planet that we think is the most like Earth, the one where we think that people could actually, make a new home and be living in a different part of our universe. So I would go there as soon as I could. But I know that before I do that, I want it to be safe. I want to understand that I'm going to get in a spaceship that's going to get there. I want to understand that I'm going to be able to come home once I've been there. And I want to understand that I can live safely there. So that's the kinds of things we're doing up here on the space station and also down on the Earth. We are getting ready to make that move.
Hi, my name is Victor Figueroa, and do you think the space program would be different if we hadn't landed on the moon?
Victor, I do think it would be different because somehow when people left our planet and then flew to the moon, landed on the moon, and could come back and tell us about it and had pictures and video to show that they were really there, I think it just affected us as people, where we realized that no matter how much we think that our everyday life is right here on Earth, we realize that we live in a huge neighborhood. We live in a universe, and our Earth is one tiny little part of that universe. And we were meant to find out what else is out there. So I think that the fact that we landed on the moon gave people the courage to be really sure about the fact that they were saying, let's go further. Let's invent spacecraft. Let's invent life support systems. And let's make sure that people are ready, kids are ready, for when they grow up to be adults to come and go to other places. And the fact that all of you today are asking these kinds of questions, you're getting ready, and I'm really proud of that.
Good morning, Cady. My name is Paul Rebel. I'm Secretary of Education for the Commonwealth of Massachusetts, and on behalf of Governor Deval Patrick, number one, I want to thank you for being such a great role model and such a great teacher in the way you've responded to students' questions today. I have the honor of asking the last question. I have a question I'm supposed to ask, and then I have a question I want to ask. So I'm going to ask two questions and take that prerogative. The first question is the scientific question. Why does the space station orbit 200 miles from Earth, just 200 miles from Earth? The second is, what would be your advice to these students as they think about careers in STEM, how to pursue their education? What was important in your educational experience? What advice would you give them?
Okay, I did get some of these questions in advance, and I saw your question, and I thought, I don't know if I exactly know the answer to why are we 200 miles above the Earth and not 300 or 400 or 100? And I think that it's a balance between, the further away from the Earth we go, the more fuel it takes to get there and to stay there, because even though we're up in space orbiting around, we're actually always spiraling back down to the Earth. We're actually always in a path to end up landing on the Earth. It's going to take a really, really long time. And so the reason I think we picked 200 miles is that it's basically what our spaceships can carry in terms of fuel in order to get us up here and actually have enough fuel to keep giving us that extra speed just to stay up here and not be falling back to the Earth. But you might want to check that answer, because that's just my best instinct. Now, your second question about what I would tell kids that are interested in science and technology. First of all, I think they're doing exactly the right thing today by having the courage to ask their questions, even though they might think that maybe they're silly questions or maybe everybody knows the answer to that question but them. They're having the courage to stand up and ask their questions, and I think that's really important to do, and it's a hard thing to do. So I congratulate all of you for doing that today, and I encourage you to do it tomorrow and the next day and the day after that too. And don't just, wait until you're talking to somebody who's up on the space station again. If you have a question for an adult about their job, do they like their job? What's the most interesting thing about their job? What do they hate about their job? What would they change in their job if they could change anything? As kids, it is your job to ask those questions, because it gets you ready for the future. And the last thing I would tell you is that there's all sorts of different aspects of becoming a new engineer or scientist or mathematician, any of those things. And in fact, any career, languages, art, music, all those things. Some people have a gift at some part of that, okay? But other parts of it are going to be hard for them. For example, for me, I like math, okay? And I'm probably pretty good at math, and I love chemistry. To me, it's just interesting, and sometimes I know the answer even if I don't even really know how I know the answer. I will tell you that physics is really hard for me. I have to think hard about every single thing. It doesn't exactly make sense to me. It's not the way that I think. Now, does that mean that physics is not for me? It doesn't. It means that physics is harder for me, and I have to work harder at physics. And so when you're doing something in the classroom and it's easy for your friend sitting next to you, but it's a little harder for you, don't think, oh, this isn't for me. Realize that everybody is good at different things, and some things we have to work harder at. And especially realize that when you do work hard at it, you're going to get it. That practice is really going to make perfect. And if you learn things step by step, you're going to know just as much as your friend next door who maybe knew it a little faster. So believe in yourselves and believe that you can be anything and you can do any of the things that you'd like to do, but you need to be prepared. It's not just going to happen. You're going to have to do the work. And I think that today you've made a good start at that by asking some really great questions.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, WGBY-TV and Springfield Technical Community College. Station, we are now resuming operational audio communications.